So let's look at the general principle or the rules for nomenclature of alkanes through an IUPAC system. IUPAC nomenclature system is an international standardized system for naming of organic compounds, which is accepted by all chemists around the world. The acronym IUPAC stands for International Unit of Pure and Applied Chemistry because it is an international organization that seeks to help advanced chemical scientists. Alkanes are basically hydrocarbons because they are made of carbon and hydrogen atoms only. They have carbon-carbon single bonds, hence they are called the saturated hydrocarbons. So let's look at the general rules or the principle for naming of alkanes. When giving an alkane molecule or compound to name, the first thing to look out for is to select the longest continuous chain of the carbon atoms and use this chain as a parent or the stem name. So let's say this is an alkane. Alkanes are basically named based on the number of carbons in the chain. If it is a 2 or a 1 carbon compound, it is called a methane. If it is 2, it is called ethane. If it is 3, it is called propane. If it is 4, butane, pentane, hexane, heptane, octane, nonane, and decane. So the first thing to look out for is to select the longest continuous chain and give this general name to the continuous chain. So here you have this compound here. The longest continuous chain is this one. This is the longest continuous chain. It has 1, 2, 3, 4, 5, and 6. So it has it has 5 carbon in the continuous chain system. This is 1, this is 2, this is 3, this is 4, and this is 5. So 5 carbons in the stem name or the parent chain. This one it has 1, it has 2, it has 3, it has 4. So 4 carbons in the longest or the parent chain. The first thing to look out for. And next, you have to number the longest chain beginning with the end nearest to a branch. So if there is a branch here, this is the longest chain named 1 to 5. You have to name the carbons and give the substituent or the branch the least number. So just start from the chain or the site beginning with the nearest branch. So if you come here, this carbon becomes carbon 1, carbon 2, carbon 3, carbon 4, carbon 5. The branch gets a number of 2. But if you come here, the branch gets the number of 4, which means that the correct naming or the correct numbering is from here. Because from here, the first branch gets the least number. So you select the parent chain, then you number them and give the least number to the first branch. Next, you name the substituent on the longest chain before the stem name and give the location of each substituent by the number of the main chain carbon atom to which it is attached. So let's say this is the compound you want to name. First, we name the substituent as the before the stem name. So the substituent here is a methyl from compound methane. So when methane loses 1 hydrogen, it is called methyl. So we name this one before the parent name, and before that we give the position of the methyl to it before we bring the parent name. So here the methyl is on the second position with respect to this direction. So here 1 and here is 2. So the methyl is on the second carbon here. So the naming becomes 2-methyl pentane. 2-methyl pentane. The 2 here means that the methyl is on the second carbon. The methyl here is the substituent here, and the pentane here is the stem name or the parent chain. Let's continue. When we have 2 or more different substituents present, we list them in alphabetical order. So substituents are basically compounds or groups which are not part of the main chain. So they can be organic or inorganic substituents. Organic substituents are made of organic atoms like carbon and hydrogen. But other substituents like, let's say, chlorine, or let's say halogens, oxygen or nitrogen, or amine groups are all inorganic because they are not organic, let's say, molecules. So this one, CH3, is an organic substituent. C2H2 is an organic substituent. Let's say when you have a halogen somewhere here being chlorine, iodine, fluorine, they are inorganic substituent. So if we have two or more different substituents present in the same molecule, we list them in alphabetical order. As seen here, we have 3-ethyl, 2-methyl pentane. So the substituents here are the ethyl and the methyl, but the ethyl start with E at the third position, then the methyl start with M at the second position. So since E comes before M, we say we start with ethyl before methyl. So 3-ethyl, 2-methyl pentane. Bear in mind, numbers and letters are separated by hyphen. Numbers and letters are separated by hyphen, but numbers and numbers are separated by comma. So take that into consideration. So with two different substituents present, we name them in alphabetical order. 5. When you have two or more of the same alkyl substituent present, we use the prefix di, tri, tetra, or and so. So here we have two methyls on the same parent chain. Two methyls on the same parent chain. So here we have two of the methyls present on the same compound. So since there are two, we use the prefix di, and we indicate their positions. So here's carbon 1, carbon 2. The first one is on carbon 2, the next one is on carbon 3. So it becomes 2,3-dimethyl pentane. 2,3-dimethyl. And di here means that we have two of the methyls and they are on the position 2 and position 3. So this di shows that we have two of the methyls present in the compound. Let's continue. When there are more than one longest chains, in the organic compound, we select the chain which carries more substituent. This one is very important. When there are more than one longest chain in the organic compound, we select the chain with the more substituent. So we have this, we have that. We can do the naming from here. Can number the carbon from 1, 2, 3, 4, 5, and leave the whole of this as a substituent. So this substituent is what we call an isopropyl substituent. Or we can also go this direction by naming 1, 2, 3, 4, 5, and we get two substituents here, a methyl and an ethyl. So keep that in mind. When there are two possible longest chain in an organic compound, what you do is you have to select the one that has more substituent on it. So if you have this one, you have only one substituent, which is what? Isopropyl. When we take this one, we have two substituents, which is methyl and ethyl. So for us to name it correctly, we select the one with more substituent, which is the second one here. So when we take here 1, 2, you have here 3, you have here 4, you have here 5. So this is the correct naming, because this naming gives us more substituent than when we take this one. So the correct name of this, as we said earlier, the ethyl comes first. So we come 3-ethyl, 2-methyl pentane, 3-ethyl, 2-methyl pentane. Not this, because this one gives us the least number of substituent. Okay, so let's continue. Let's continue with our structure. We have here. Okay, so let's continue. Go to the side. So we are at point 7 here. This one. It says when two substituents are present on the same carbon, we use that number twice. So we have the two substituents on the same carbon, we use that number twice. So it's very simple. We have methyl group here and an ethyl group here. So this is the ethyl group here. This is the methyl groups. They are all on the carbon 3. This carbon 1, 2, 3, 4, 5, 6. So these two substituents are on the same carbon or the same position. So we use that number twice in our naming. So it's very simple. It becomes 3 ethyl first because the E is before the M. 3 methyl again before hexane. It's hexane because it is a 6 carbon atom in the parent chain. Next, let's continue and look at our final point here. The last rule in naming alkanes here is when branching first occurs at an equal distance from either end of the longest chain, number the chain from the end in which the second substituent nearest the first substituent. So this one, let's try and explain this one here, this rule. We can number the chain from here 1, 2, 3, 4, 5, 6, or we can also number from 1, 2, 3, 4, 5, 6. So in that order. Now, if you have two branches or two substituents at the same or equal positions at both ends of the parent chain, what we do is we choose the one that gives the least number to all the substituents. So let's see, if we start from this direction, we can have carbon 1, carbon 2, carbon 3, 4, 5, 6. So the name becomes 2, 3, 5 trimethylhexane. So this is the correct one. But if we are to go this way, we have carbon 1 here, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. In that case, this one assumes carbon 4. This carbon assumes carbon 4. So it becomes 3, 4, 5 trimethylhexane. Because this one will assume a highest number, it becomes a wrong number. So the correct one is to set from direction or the side that gives the least number to each of the substituents. So these are the general rules for naming alkanes. Don't forget, when we have every alkane losing one hydrogen, it assumes an alkyl group. So methyl losing one hydrogen becomes methane, losing one hydrogen becomes methyl. Ethane losing one hydrogen becomes ethyl. When we have butane losing one hydrogen becomes butyl. Let's say octane losing one hydrogen becomes octyl. So these are all substituents that occurs at the parent chain. Thanks for watching, and don't forget to subscribe to the channel so you can receive every update from this channel. Thank you.